All right, for the 5.3 practice, this is just review. 5.3 was the section that had all the inverse functions, so it's kind of a good thing to practice here. So this says find f inverse prime of a for the function f and real number a. And then there's this hint, use the calculator to find b such that f of b equals a. So for these, it's telling us to go ahead and just use a calculator. But the general process here, the first thing you should do is figure out where f of x is equal to a. Because remember, if we're on the f inverse graph and we're trying to find f prime at the point ab, then that equates to where f of x has a point of b a. So 1/27 times x to the fifth plus 2x cubed is supposed to equal negative 11. So this says use a calculator, so I won't argue with that. So I'm going to put this in 1/27 times x to the fifth plus x to the 2x to the third. Insert a little 2 in there. That's the first line. When is this equal to negative 11? I'm going to zoom 6 on this. I know that's not going to show me negative 11, but just to get my x values right. And then I'm just going to drop the window down. I just need negative 11 to show up, so maybe I'll drop this down to like negative 12. There we go. So I'm going to find this point of intersection. It is negative 3. That's a nice number. So this happens when x equals negative 3. So then step 2 is to find f prime of x, f prime of negative 3. So I'm going to find f prime of x first. And actually, I guess if we're using a calculator, you have these types of problems on no calculator, but I guess the reason we're using a calculator is because the numbers are kind of difficult. If it's x to the fifth and 2x to the third, that's not something we can easily factor with a constant. So I'm going to do this part, I think, without a calculator. We'll see. So 1/27 f prime would be 1/27 times 5x to the fourth. Maybe I won't. Plus 6x squared. And then we're supposed to plug in negative 3 into that. So, I don't want to waste time on that. So, just to speed things along, I'm just going to say, all right, I already have this equation in my y1. So that's fine. And let's evaluate this at negative 3. So it looks like it's 17. 17 or negative? 17. So step 3 is applying the relationship we know between f inverse prime and f prime. So the rule is f inverse prime of negative 11 is equal to the reciprocal 1 over f prime of negative 3. So that means our answer is 1/17. All right, so let's do that again. I don't know if we're supposed to be using a calculator for each of these or not. Let me see. Did I do this on my other key? Well, I guess I did. Now, how do I have 1/18 here? I must have had a typo there because I think unless I have a typo here, yeah, I think this is correct. All right, now it looks like I did not use a calculator for those other two. So I'm going non-calc for these two. All right, so what would that look like? So again, first step is set f of x equal to a. So 1 equals cosine of 2x. We're only getting answers in the first quadrant between 0 and pi over 2. So when is cosine equal to 1? So when the angle 2x is equal to 0 or 2 pi or 4 pi, etc. If I divide by 2, I get 0 and pi. We're only looking for answers between 0 and pi over 2. So what's happening there? 0 and pi. Oh, duh. We're allowed to use 0. Sorry, I was thinking open interval. Okay, so pi is out, but 0 is good. All right, so now I want to find f prime. What's the derivative of cosine of 2x? So the derivative of cosine is negative sine of 2x, and then we need to remember to multiply by the derivative of 2x, which is 2. So we're evaluating f prime at 0. So that's going to be negative 2 times the sine of 0. Sine of 0 is 0. So f prime of 0 is 0. All right, now this is going to be a problem, right? Because we're trying to find f inverse prime of 1, and that's equal to 1 over f prime of 0, and that's equal to 1 over 0. So that means that f inverse prime of negative 1 does not exist. Or I'm sorry, of positive 1 does not exist. All right. I think that makes sense because looking at this, on the f of x graph, the cosine of 2x, if I'm evaluating the inverse function, if I'm trying to plug in 0 there, I have a feeling there might be a horizontal tangent, right? Or we know there's a horizontal tangent at f prime. So flipping that around, it'd be a vertical tangent here. So that's why that's not working. All right, let's do this one without a calc. So we need to say 6 equals, do we want to do this one without a calc? Maybe not. X to the third minus 4 over x. Actually, no, I can do this without a calc. I'm guessing that it's probably 2, right? Let's check this. If I plug in 2, is 6 equal to 8 minus 4 over 2? Yeah, 6 is equal to 8 minus 2. So, okay, so x equals 2. That's doable without a calculator. It's not going to be no calculator, and then the answer was like 1/16 or something like that. So, okay, so we know that. And then 2 is find f prime. So the derivative of x cubed is 3x squared. The derivative of minus 4 times x to the negative 1 is plus 4 times x to the negative 2, or over x squared. And then you want to evaluate that at 2. So that's 3 times 4 plus 4 over 4. So that's 13. And then the third step is to say f inverse prime of 6 is equal to 1 over f prime of 2. And so that's equal to 1/13. All right, next problem. Show that the slopes of the graphs of f and f inverse are reciprocals at the indicated points. So yeah, the relationship only works for the points that you would be reflecting across y equals x. So if I just need to show that that's true, I have equations for both. I'm just going to find the derivative of each and plug in their corresponding numbers. So f prime of x is equal to 3x squared, and f prime evaluated at 1/2 would be equal to 3 times 1/4, so 3/4. And then f inverse prime of x is equal to 1/3, and then it's x to the negative 2/3. So let's put cube root of x squared down here, right? Because we're doing x to the 1/3 and then you subtracted 1. And then we are evaluating f inverse prime at 1/8. So that's 1/3. And then let's see, cube root, instead of squaring, well, no, it doesn't matter. You can cube root 1/8 first and then square it. Or you could say that's the cube root of 1/64, which is 1/4. So 1 over 3 times 1/4. So 1 over 3/4 is 4/3. So yes, those are reciprocals of each other. All right, same thing for this one. So let's rewrite f of x so that it's 4 times 1 plus x squared to the negative 1. I don't want to do quotient rule. I prefer to do power rule here and chain. So f prime of x is equal to negative 4 times 1 plus x squared to the negative 2. Don't forget to chain rule. The derivative of 1 plus x squared is 2x. So f prime of x is equal to negative 8x over 1 plus x squared squared. And then f prime evaluated at 1, because that's what the point says, is equal to negative 8 over 1 plus 1 is 2. 2 squared is 4. So negative 2. All right, so f prime of 1 is equal to negative 2. So we're looking to see that this inverse derivative should be equal to negative 1/2. So let's check that out. All right, now this I would simplify to say, okay, this is all underneath the square root. So this is the square root of, well, actually, let me rewrite it as 1/2 power. Let's go ahead and divide. So this is 4x to the negative 1 minus 1. Raise that to the 1/2 power. So when I find f inverse prime of x, it's power rule first. So 1/2 times this quantity to the negative 1/2. And then what's the derivative of the inside? So this becomes negative 4x to the negative 2. And then the derivative of 1 becomes 0. And then let's clean that up. We're going to plug numbers into it, but I like to clean things up. So 1/2 times negative 4 is negative 2. This x to the negative 2 will come down here, x squared. And then this negative 1/2 will be the square root of 4 over x minus 1. So there's f inverse prime of x. Now let's find f inverse prime of 2. So that'd be negative 2 over 2 squared is 4 times the square root of, looks like an index, 4 times the square root of 4 over 2 is 2 minus 1. So yeah, negative 2 over 4 is negative 1/2. So f inverse prime of 2 was equal to negative 1/2. Those are reciprocals of each other. Find dy dx at the point negative 4, 1, where x equals y cubed minus 7y squared plus 2. So, all right, so we can't easily solve this for y, so we're going to take the derivative with respect to x of both sides of the equation. And the derivative of x is 1. The derivative of y cubed is 3y squared, and we have to chain rule dy dx. The derivative of minus 7y squared is minus 14y, chain rule, dy dx. Derivative of 2 is 0. And then we clean things up so I can factor out a dy dx, which would leave me with 3y squared minus 14y, and that's still equal to 1. So I'm going to bring this up here. So dy dx is equal to 1 over 3y squared minus 14y. We were told to find dy dx at this point, so evaluate dy dx, evaluate at the point negative 4, 1. Negative 4 is the x, 1 is the y, so we're just plugging 1 in, really. 1 over 3 minus 14, this seems familiar, I feel like we had this problem, is negative 1/11. This was either in a homework or notes somewhere. All right, number 7. The derivative of the function y equals tangent x has the same sign for all x in its domain, but the function is not 1-to-1. So what is this even talking about? So remember, this said if a derivative is, remember what we said, if f prime is greater than 0 for all x, then f is monotonic. So that's what this is referring to. And if f is monotonic, then f inverse exists. So why isn't that true for this? I think the stipulation for that was that f of x needed to be continuous. This is only true if f of x is continuous. For all x that we're looking at. So it's only true if f of x is continuous on all real numbers, and therefore tangent x is not continuous. That would be my explanation. We talked about how you need to restrict the tangent x graph between negative pi over 2 and pi over 2 to get it to be 1-to-1. Another way you could explain this is like, yeah, tangent x is periodic. So not one-to-one on its entire domain. True or false? Explain. If the inverse of f exists, then the y-intercept of f is an x-intercept of f inverse. Again, I believe this came from a homework. I feel like I've answered this question before. So the stipulation here is already we know that f inverse exists. So this has to be true because the y-intercept of f, so on f of x, the point 0, y exists. Let's call it, instead of y, let's call it 0, a exists. Then on f inverse of x, that point has to become a 0. So yes, what was once a y-intercept is now an x-intercept. All right, let's get into integration. So find the indefinite integral. These are examples of things we could see either in multiple choice or on our test. We have 3 integrals that you're just doing the work for and writing the answer on the blank, kind of like the short quiz. And yeah, they're like these. So 9 minus x squared. I see x over the square root of 9 minus x squared. Normally, the square root of 9 minus x squared is arc sine, but there's an x up here. And so that means this is probably u sub. Because arc sine does not have an extra x up here if this is just x squared. All right, so I'm going to let u equal 9 minus x squared, the whole thing. Du dx will equal negative 2x. You can solve this for dx by multiplying dx over and then dividing by negative 2x. So if you set this up, you've got x on top, you've got the square root of u on the bottom. Dx is now du divided by negative 2x. The x's should cancel. That's how you know u sub worked. Let's put the negative 1/2 out in front. And if it's 1 over radical u, let's make that u to the negative 1/2. Okay, now we're ready to integrate. So this is negative 1/2. And then add 1 to this exponent, you get u to the 1/2 over 1/2. So that's 2 times u, which was 9 minus x squared, to the positive 1/2 power, plus c. And I'll just clean that up a little bit. It's negative square root of 9 minus x squared plus c. That's my answer for number 9. For number 10, I see a denominator that has a higher degree than a numerator, so I'm going to let u equal the denominator, x cubed plus 3x squared plus 9x. Du dx is equal to 3x squared plus 6x plus 9. Let's solve that for solve that for dx. And I'm noticing I can factor 3 out. X squared plus 2x plus 3. And that's a good sign because I have that exact expression here. So when we rewrite this, x squared plus 2x plus 3 is up there on top. The bottom was made into u. Dx is du divided by 3 times x squared plus 2x plus 3. Now, if you don't have to show all of this work, I would love for you to get to a place where you can just not have to do all this rearranging and solving and just get it to 1/3 times the integral of 1 over u du. Saves you writing and a little bit of time. But if you're nervous about it or you feel like you're going to mess up a step or if you didn't do so well on our short quiz, I highly suggest then going through all of these steps every single time. So this is 1/3 times the natural log of the absolute value of u, which was x cubed, plus 3x squared plus 9x plus c. All right, next one. Now remember, you can expand a logarithm a little bit. Let's work on this. Let's make it the integral of 1 over, so natural log of x to the third can be 3 natural log of x. That might make life a bit easier. So that means that if I pull a 3 out, I'm going to make it like 3x natural log x dx. That's easier because that lets me say u is ln x. Du dx is just easier to find. It's just 1 over x. Instead of 1 over x cubed times x squared, it would still get me to 1 over x. And see how we have 1 over x dx? So we have du in here. If you're not sure on that, you would say multiply dx over to this side, divide by 1 over x, or multiply x over here. So you're going to have the integral of, let's pull a 1/3 out, 1 over x times u, and then dx is x times du. So see how the x's cancel? So that's 1/3 times the natural log of the absolute value of the natural log of x, that looks weird, plus c. All right, what about cosecant? The integral of cosecant. Oh, now see, I said that I wouldn't give you these. We definitely don't have the integral of cosecant on our test because this is one that I said, even I don't have it memorized. So I need to go back and look at what this even is. So, because you have to make it you can make it 1 over sine of 2x. And that's not a nice, easy u sub to make. And there was this whole crazy, you have to really manipulate it with trig. What am I saying? Trig identities to get this to something you can u sub. So let's see, what notes were these in? Was it inverse trig? Was it integration of logs? Oh, where was this? Let's see. Nope. Was it back here? Here we go. What is the integral of cosecant u? It's negative ln. You know what? I'm gonna do this. I'm not gonna remember that. So, are we gonna have to do this on our AP test? I kind of doubt it because this is one that you can't very easily come up with if you haven't memorized it, and they're not in the business of, there's stuff we need to memorize. Okay, I can't get that to move up. There's stuff we need to memorize, but not usually to this degree. So, okay. So it's negative ln. So let's establish u first of all. U is 2x. Du dx is 2. Du divided by 2 is dx. So that means that before you get into what this is, if I want to make it cosecant of u, I'm going to have du divided by 2. So I'm going to need a 1/2 out there. Okay, now I'm ready. It's 1/2 times what? Negative natural log of absolute value of cosecant u plus cotangent u. So cosecant 2x plus cotangent 2x plus c. Did I get that right? Yeah. Clean that up. Negative 1/2 out in front. Natural log of all this stuff. That looks a little bit better. All right. I want this to be blue and not red. Sorry, aesthetics here. All right. What about this last one? So for this last one, we have secant times tangent over secant x minus 1. Let's see. Can we work on this a little bit? This is cosine. Now, secant tangent is the derivative of secant. So maybe we should just go ahead and do a denominator again. So u equals secant x minus 1. Because there were no obvious things that would cancel if I changed everything to sine and cosine. Du dx is secant x tangent x. So yeah, secant x tangent x, that is du. So this is really just the integral of 1 over u, and we already have du. Or, dx would be du over secant tangent. They cancel. So that's the natural log of the absolute value of secant x minus 1 plus c. All right, what about this? Let me get this out of here now. Okay, so find f inverse prime of 3 and f inverse prime of 4. All right, now for f inverse prime of 3, it's equal to 1 over f prime of not 3. It's equal to whatever makes f of x equal to 3. So what makes that happen? F of x is equal to 3 when x equals 1. So it's equal to 1 over f prime of 1, and that is equal to 1 over f prime of 1, 1/2. 1 over 1/2, 2. What about f inverse prime of 4? That's equal to 1 over f prime of not 4, but whatever makes f of x equal to 4. So where's f of x equal to 4? That's right here. When x equals, oops, I wrote 1, sorry. When x equals 0. So that's where this is coming from. What is f prime of 0? Negative 3. So negative 1/3 is my answer. Find the derivative of the function. Now, for logs, if they have something ugly inside of them, you should expand. I'll just tell you right now, in our free response question, you need to expand the log to make life much easier. They even tell you, hint, if you're clever, you can rewrite the log in such a way that blah, blah, blah. So you can expand or you can use change of base to make life easier. So this would be y equals 1/3. And then it would be natural log of x minus 1 minus natural log of x plus 1. You can have the 1/3 distributed through if you want or not. I need to find the derivative, so I want to find dy dx or y prime. All right, so 1/3 is out there. The derivative of natural log is 1 over x minus 1, technically times the derivative of x minus 1. And then minus 1 over x plus 1, again, technically times the derivative of x plus 1. I just point that out because if this expression has a derivative other than 1, then that matters. And I'm just going to leave it like this, actually. This is x squared times ln x, so remember that you have to use product rule here. So when I go to find y prime or dy dx, it's first times derivative of the second plus second times derivative of the first. And let's clean that up a bit. So this is x squared times 1 over x is just x, plus I like putting the 2x out in front, 2x ln x. The natural log of cosecant. So I guess you could make this 1 over sine and expand it out, but I think I'm just going to get into it here. So y prime, or dy dx, is 1 over cosecant x times, what's the derivative of cosecant? It's negative cosecant x cotangent x. Derivative of 6 is plus 0. The cosecants cancel. You've got negative cotangent x. And I would just leave it like that. What about this one? You can get the square root out of there because you don't want to have to deal with all that chaining. So this is the same as 1/2. And let's pull the 1/2 out. And then the natural log of, I almost did a trig identity, but 1 plus sine squared does not simplify. So I was thinking cosine squared, but that's 1 minus sine squared. All right, so what is dy dx going to be? There's a 1/2 there. The derivative of a natural log is 1 over the thing in the natural log. And then what is the derivative of 1 plus sine squared? So derivative of 1 is 0. Derivative of sine squared, so you're doing something squared, and then you're doing sine x. So the power rule is 2 sine x. The derivative of sine x is cosine x. So let's see, the 2's cancel. Sine x, cosine x over 1 plus sine squared x. There are no obvious identities to really do to mess with this, so I would just leave it like that. Okay, now number 19, this is more like chapter 6. I used to combine chapters 5 and 6 together, or part of chapter 6, I should say, was in with chapter 5. I think we can still do this, but you don't have to worry about differential equations being on our test tomorrow. So, okay, so the function is differentiable. F is differentiable for all real numbers. The point 3/1/4 is on the graph. And the slope at each point on the graph is given by dy dx. Find the second derivative. So we've already done that before and evaluate it at this point. So to find the second derivative, you're taking the derivative of the first derivative. That's the second derivative. And then I need to do product rule here. So the derivative would be first times derivative of the second plus second times derivative of the first. Now remember, the derivative of y squared with respect to x is 2y dy dx. Okay, so that's negative 2y squared plus 2y times 6 minus 2x. And get this dy dx out of here. That's y squared times 6 minus 2x. I'm not going to simplify this too much. I'm going to clean it up a little bit, but we're just plugging a number into it. So don't worry too much about factoring stuff out. I just can't stand to leave it like that. So I'm going to say, okay, that's negative 2y squared. And then 2y times y squared is plus 2y to the third. And I have two of these, so I'm going to make it times 6 minus 2x squared. Now we need to evaluate the second derivative at the point 3 1/4. 1/4 is 3 is the x, 1/4 is the y. So that's negative 2 times 1/4 squared, 1/16, plus 2 times 1/4 to the third, 1/64. Excuse me. Times 6 minus x. So 6 minus 6, 0 squared. So that's cool. That's 0. And this just comes out to negative 1/8. All right, part B. Find y equals f of x by solving this differential equation with the initial condition. So this is really the chapter 6 thing. All right, so the hint here says must get y squared with dy and 6 minus 2x with dx. So here's a preview of something that's coming down the line in chapter 6. What that means is, we often solve for du or dx or whatever. So let's leave dy over here. Let's multiply dx over here. Now to get the y squared to this side, we're going to have to divide it. dy divided by y squared is equal to 6 minus 2x dx. That's called separate. The next step is integrate. Separate, integrate. Celebrate is going to be our last thing with plus c. So what is the integral of y to the negative 2? It's y to the negative 1 divided by negative 1. What's the integral of 6? 6x. What's the integral of 2x? Minus 2x. Minus 2x squared over 2. And then there's a plus c. So this is negative 1 over y is equal to 6x minus x squared plus c. We have this initial condition right here. How do I find c? I plug in 1/4 for y. So negative 1 over 1/4 will be negative 4. I plug in 3 for x, so equals 18 minus 9 plus c. Negative 4 equals 9 plus c. Negative 13 equals c. Okay, so that brings me back to here. Negative 1 over y is equal to 6x minus x squared minus 13. Now we want it to be y equals, so I can say I'm going to multiply y over to this side, but not actually multiply it through. And then turn around and divide by the parentheses. I'm going to put this in the right order as well. So there's my equation for y. This is not on the chapter 5 test. It is chapter 6, but we will be doing that shortly. And you do have the skills to do all of this. You just might not have known how to get it started. All right, that was the last problem. Come and see me in office hours if you have any questions on this or if you'd like more practice on any of the stuff we're looking at.